In this video, we will look at piecewise functions, which are simply functions made up of pieces of other functions. As we consider piecewise functions from left to right, we can think of them as changing shapes from one to the next at certain points along the x-axis. But these shapes are functions, which means we are changing what is done to the input variable at certain points. In this way, piecewise functions are analogous to many things we experience in life. Our day-to-day routines have many points where we stop doing one thing and start doing another. When we wake up, the function sleeping changes to the function awake. When we're done with work, the function working changes to the function doing whatever I want to do. If we're at a buffet, at some point we move away from the salad function to the dessert function. In the realm of video and audio, piecewise functions abound. In video libraries on our phones or computers, some programs show the whole video as a long strip with thumbnails throughout showing different parts. In fact, here's the timeline I see in the video editing program I used to make this video. The thumbnails are snapshots of the different pieces of the video. With television shows and movies, there are different acts and scenes, which are different pieces of the whole program. Pieces of music act the same way. There are different parts which make up the whole, and in those different parts, there are different functions for volume, tempo, pitch, and timbre. In another video, we looked at the envelope on a synthesizer as a function. Here's that same function again, and we can notice that it is in fact a piecewise function. At the beginning, there is a rise. Then at some point, it starts to fall to a sustain level, and at the end, the sustain changes to a release to 0. There are 4 functions: attack, decay, sustain, and release. We saw this function applied to volume, pitch, and timbre in that video. But we can also hear analogous versions of this same function in recorded music. Let's explore some other piecewise functions and how we might hear them in music. First, the step function. This function looks exactly as it seems in its title: steps. When we walk on steps, the steps are horizontal pieces that are parallel to the ground, and they take us up or down. If we graph the step function, it is just made of constant functions, or horizontal lines. A general step function might extend infinitely up and down, but most steps we see are not infinite. In music that we listen to, there are a finite number of steps that can be used to make a melody, and we call these steps notes. When you look at a piano, there are 88 keys or notes that can be used. If you play one note at a time, you are using a version of a step function, since each key represents a note that stays constant as long as you hold the key down. Listen to the following notes that are played and try to think of what the step function might look like. And we can make our own version of the step function by playing a simple melody. When we look at the musical notation for the melody, we are seeing a version of this function that is read from left to right. The horizontal axis relates to time, with the beginning being t equals 0, and the vertical axis is related to pitch. Another specific piecewise function is the absolute value function. The absolute value function does one thing. For any input, the output is the distance that the input is from 0. For example, the absolute value of -5 is 5, since the number -5 is 5 units from 0. This function may not have a direct use in music made with acoustic instruments, but it is very useful in electronic music. There is an electronic circuit called a rectifier that will convert alternating current to direct current. In application, it can take a waveform that has positive and negative voltage and return a waveform that has only positive voltage. We can see some uses of the rectifier with the following. Wave shaping. We can change the timbre of a waveform by changing its shape. The negative part of the waveform is transformed to positive. We can take a sawtooth waveform and convert it to a triangle waveform. Or we can take a sine wave and create a different waveform entirely. With the outputs in both of these examples, notice the V shape we get at certain points in the graphs on the oscilloscope. Modulation. Modulation is a word representing change. With some modulation, it may be preferable to have only positive voltages affect a change. Let's listen to a triangle wave modulating pitch. versus a rectified triangle wave modulating pitch. Modulating pitch is called vibrato, and you can hear this done by many popular singers. What we can notice in our example is the triangle wave modulating the pitch sounds like it takes longer, and this is because it rises above the bass pitch, then goes below, and then back above, etc. But the rectified triangle wave keeps the pitch above the bass pitch, and in this way it doesn't have as large of a range to go through. We can see this when we plot both waves together on the same coordinate axis. Notice that the triangle wave in green has peaks above 0 and valleys below 0. The rectifier turned those valleys into peaks, but what was returned in blue is still a triangle wave. When synthesizing a sound to be more natural with vibrato, the rectified triangle wave for modulation is sometimes a better fit. With these examples, we actually saw and heard a lot of piecewise functions. Sawtooth and triangle waves themselves are piecewise functions, but they are periodic, meaning they repeat as we look at them from left to right. And when we put their values into the absolute value function with the rectifier, we got other piecewise functions out.